All right, first we need to review factoring a little bit. I know we've done it a lot, but I do know that some of us need the refresher. So reviewing factoring, if we have a quadratic expression in the form of ax squared plus bx plus c, we need to first do a times c. Well, let's look at the expression of x squared minus 5x minus 6. A is 1, c is negative 6, so a times c is negative 6. We need to find factors of negative 6 that add to negative 5. I know 3 and 2 add to 5, but negative 3 and negative 2 add to negative 5, but multiply to positive 6. So the factors we have to use are negative 6 and positive 1, or positive 1 and negative 6, doesn't matter. So then we rewrite our quadratic expression with the answer from above, so with negative 6 and positive 1. So I have x squared minus 6x plus 1x minus 6. Then from there, we factor by grouping, which if you remember, we take the greatest common factor out of the first two terms. So the first two terms share an x, so I'm going to factor the x out, leaving me with x minus 6. Then last one, the only term, or the only factor it shares is a positive 1, so I factor a positive 1 out, and that again leaves me with x minus 6. If you remember, we need what's inside the parentheses here to be the same. So I factor out the x minus 6, leaving me then with x plus 1. So my two factors, or x squared minus 5x minus 6 in factored form, is x minus 6 and x plus 1. Remember, to make sure it's in simplest factored form, we look at our final factors, and as long as each set of factors does not have a common factor that can be removed, like x minus 6, its only common factor is 1, x plus 1, only common factor is 1. So there's nothing that can be removed, therefore x minus 6 and x plus 1 is the simplest factored form of x squared minus 5x minus 6. Now we are going to use that refresher on factoring to simplify rational expressions. We actually did this on our SLO. When you simplify radical expressions, so for instance in this problem we have 2x squared minus 3x minus 2 divided by x squared minus 5x plus 6. What we need to do to simplify this is factor both the numerator and the denominator. So in this case, I don't have my steps written just because it would have taken me all night to do this. So we do a times c, so 2 times negative 2 is negative 4. Find our factors of negative 4 that add to negative 3. So it's going to be negative 4 and positive 1. So I rewrite the 2x squared minus 3x minus 2 as 2x squared minus 4x plus 1x minus 2. And then I factor by grouping. So in my first pair, I can take out a 2x. Leaving me with 2x, x minus 2. And then my last pair, I can only factor out a 1, so plus 1, and leaving me with x minus 2. X minus 2 is the same, so I factor the x minus 2 out. And my factors, as stated here, are x minus 2 and 2x plus 1. Again, order doesn't matter. And I look at each set of factor, 2x plus 1 doesn't have a common factor that can be removed. X minus 2 doesn't have a factor that can be removed. So that's its simplest factored form. So then we look at our denominator, x squared minus 5x plus 6. We need to factor that as well. So a times c is 6 factors of 6 that add to negative 5. Well, here is where we'll use negative 3 and negative 2. So I rewrite my expression as x squared minus 3x minus 2x plus 6, factor by grouping. So I take out an x, and I have x minus 3. And in the second pair, I can factor out a negative 2. So leaving me with negative 2 parentheses x minus 3. X minus 3 is the same, so I factor out an x minus 3, leaving me with my factors of x minus 3 and x minus 2. So there is everything completely factored. Now, to simplify rational expressions, we cancel out identical factors because when we divide those, they'll equal 1. So x minus 2 divided by x minus 2 equals 1, so we can cancel that out. And we are left with 2x plus 1 divided by x minus 3. These aren't common factors. There aren't identical factors, so we can't cancel them. So that is it in simplest simplest rational form. One last piece we have to do is state restrictions on the domain. So we have to look back originally at our factored form of the original expression. And remember, we can't divide by 0. So we have to say the restrictions on our domain here is x can't equal 3 and x cannot equal 2, because those are the two values one plugged in for our denominator would make the denominator equal to 0. We're going to do another example of this here. Okay, simplifying rational expressions again. Here we have -6 minus 3x divided by x squared minus 6x plus 8. First thing I like to do is, with my numerator, rewrite it so it's in standard form. So it's going to be -3x minus 6. That is not a quadratic, so I don't have to do a times c. I simply just factor out my greatest common factor. And remember, we never want our leading coefficient to be negative. So I'm going to factor out a -3. And in doing so, I'll have -3x plus 2. My numerator is completely factored. Let's move on to the denominator. So here, again, a times c, it's a quadratic, so we'll do a times c. 1 times 8 is 8. Factors of 8 that add to -6 are -4 and 2. So we're going to have x squared minus 4x minus 2x plus 8. Once we go through the process of factor by grouping, we will have x minus 2 and x minus 4 as our factors. So again, now notice we can only cancel out identical factors. Notice we don't have any. We have an x plus 2 and an x minus 2, but they're not identical, so we can't cancel them out because when divided, they don't equal 1. So really all that's left for us to do is state restrictions on the domain. And we would say all real numbers except x cannot equal 2 or 4, because those are both the values of x when plugged in that would make our denominator equal to 0. Okay, multiplying fractions. Let's start back to the basics. Like for instance, if I have 1/3 times, I think that's 4/3, so no, 4/5. 1/3 times 4/5, we do 1 times 4, which is 4, and 3 times 5, which is 15, 4/15. They don't share a common factor, so that's it, we're done. You just multiply straight across. So that's why when we have 2/3 times 10/7, sorry, that's 2/5, goodness. 2/5 times 10/7. Notice I simplify first because I know that the denominator 5 here and the numerator 10 here have a common factor of 5. So I can divide each of those terms by 5, leaving me with 2/1 times 2/7, or 2 times 2/7. So when I multiply that, it's going to be 4/7. Multiply our numerators. That's what I call cross simplification. You simplify first and then you multiply. It will make your life a lot easier in this process. So like I put here, same rules apply to rational expressions. When we multiply straight across. I'm going to skip the step of factoring here. It might be a great point for you to pause the video and actually look at this problem, factor every piece, and once you have it factored, then you can turn the video back on and look. So here's the factored form. So really it's 2x plus 1 times x plus 3 divided by x minus 4 times x minus 4 times x plus 4 divided by x plus 5 times x plus 3. So that multiplied together is really just multiply the numerators, multiply the denominators. But we're going to simplify before we do any multiplication. And because x minus 4 is down here in the denominator and up in the numerator, it can cancel. We also have an x plus 3 in both the numerator and the denominator. That can cancel. So that will leave us with 2x plus 1. Sorry, that should be a plus 1. That will leave us with 2x plus 1 and x plus 4 all over x plus 5. And that would be our final answer. So we could then state restrictions on the domain and say, well, x cannot equal 4, -5, or -3, because any of those values when plugged into the original equation would make the denominator equal to 0. Okay, now it's time to talk dividing fractions. Again, we're going to start back with the basics. So we have 1/2 divided by 1/2. Well, if you type that in your calculator, you would get 1, because basically what your calculator is doing 1/2 times 2/1. And because with multiplication, we multiply straight across. 1 times 2 is 2, 2 times 1 is 2, 2/2 is 1. So the same rules apply to rational expressions. If we have 6x plus 6y divided by x minus y, or sorry, 6x minus 6y divided by x minus y, and then that expression divided by 18 over 5x minus 5y, that can be rewritten as, well, I factored my expressions too. I kind of killed 2 birds in 1 stone. with one stone. So I factor the numerator of 6x plus 6y, take the 6 out, we have 6x plus y over x minus y. And then this turns into times the reciprocal of the second fraction here. So it's times, factor out the 5, x minus y over 18. Now we can cross simplify and then multiply. So the x minus y factors here will cancel. 6 and 18 are both divisible by 6, so I divide them each by 6, and then I'll be left with 5x plus y, my numerator, all over 3. And then, of course, lastly, we have to state the restrictions on the domain, and this is kind of funky because the only restriction is that x can't equal y. So x could be 0 and y could be 7. That works out. It's just x and y can't be the same number. Why don't we move on to the checkpoint quiz here, and if we have any further questions, I'll be able to answer those in class. Thank you. Have a nice day.